Hello and welcome to Arithmetica. This video is the third episode of our program in propositional logic. In the previous video, we introduced the concept of logical connectives used in forming compound statements, in which we presented our first in this series, the conjunction. Another commonly used connective is the disjunction, which is usually expressed by the word or, and is denoted by the wedge symbol. However, a word of caution is warranted. The everyday use of the word or is used to connect at least two alternative words, clauses, sentences, etc., and it takes the form of two different meanings, the inclusive or and the exclusive or. The exclusive or is frequently used where we refer to one thing or the other, but not both. For example, if someone says at the end of this road turn left or go straight on, then they are using the exclusive or. But what if someone said Jill has put her coat on or she has worn her scarf? Here we cannot exclude the possibility of Jill wearing both a coat and a scarf. In such cases, where one refers to at least one thing or the other, i.e. exactly one or the other or both, then we are using the inclusive or. However, in the philosophy of logic and language, and that of mathematics, we must avoid such ambiguity. Consequently, any reader of logic should be aware that we employ the inclusive or, that is, the disjunction of P and that of Q is read as at least P or Q, or equivalently, only P, only Q, or both P and Q, where the component propositions P and Q are called disjuncts. And so, unlike the exclusive or, it is meaningful to consider both P to be true and Q to be true. This leads us to the following truth table, as a matter of definition for a disjunction of two arbitrary propositions P and Q. Whereas one might expect from one's intuitive notion of the inclusive or that it can only be false if both P is false and Q is false, which is indeed the case as shown here in the truth table. Therefore, the disjunction Nelly is an elephant or Nelly has big ears only requires at least one of its disjuncts to be true in order to guarantee itself in being true. A simple example of a disjunction in mathematics is by stating that the real number x is greater than or equal to 0, and is the disjunction of sentences the real number x is greater than 0 and the real number x is equal to 0. Strictly speaking, these are not statements, owing to x being perceived as a variable, and so to avoid ambiguity, we might choose to state this thusly. Let x be a non-negative real number, then x is greater than or equal to 0. Mathematically, we may write this thusly, where we have used the mathematical symbol for set membership as well as the operator greater than or equal to. Thus, for this statement to be true, we need only require an arbitrary selection from the defining interval in which such an x has the property in which x is greater than 0 to be true or x is equal to 0 to be true. Another example in mathematics would be the disjunction x belongs in the set of rational numbers or it belongs in the set of integers. Although there is some ambiguity in this sentence, since as x is a variable, this will be true for some real numbers x, but false for others. Thus, this is not strictly speaking a statement in propositional logic, but can serve the purpose in defining such a real number. Regardless, we can symbolically write this thusly. Of course, if we wished to define a set on this disjunction, then since the set of integers is a subset of the set of rational numbers, it follows that we simply obtain the set of rational numbers. This therefore also provides an example where it is possible for x to belong in the set of integers, and therefore it would also belong in the set of rational numbers, such that the disjuncts are both true. Thank you for watching this video of our introduction of the disjunction operator. In the next episode of Arithmetica's introduction to propositional logic, we will consider a somewhat different type of logical connective. You might also be interested in watching the accompanying video of exercises for this episode. Please feel free in clicking on the annotation or alternatively on the link in this video's description. And so until next time, it's goodbye from Arithmetica!